Alright guys, so welcome back to the second video, sort of, to speak about the grass. So here I wanted to talk about technical stuff, what I had to change in the engine itself in order to make it work. So the first thing I broke was the debug renderer. Okay, so basically debug render is a really simple render that basically renders just line, points, like solid colors, you know, like no shading, super simple. And we can actually see in action. So now the engine has basically two cameras. One is the active camera, one is the main camera. And basically the active camera can swap between the main camera and a debug camera. So if I press Shift C, you see that basically my camera snaps back. This is where the debug camera is. They start both in the same position. And we can see that's where my actual main camera is, and I'm rendering the frustum of the camera. So you can see I can keep jumping back and forth between the two, which with Shift C. And so this one is an example of the debug render, right? So the frustum is being rendered using the debug renderer. You can see the near plane, the far plane, which is actually being clipped, which is fine. But because basically I was rendering the tiles on the ground. Actually, we might still be able to see the tile. If we go into the grass, here we go. There should be a tile debug that I comment out. Dirty stuff here. This shouldn't be here anymore. It was testing stuff. Here we go. So if I run this now, there you go. So you can see the tiles that I was talking about in the other video, right? So if I change the number of tiles, you can see reduce, increase. So I was debugging this, right? So I needed to show that, and basically I broke it. And also by talking to other people on Twitter, other graphics people, I realized my debug render was so complex. Basically the way it works is that it supported two types of rendering. Persistent rendering, basically something you want to render every frame, and something you want you want to render one frame. So for example, let's say I'm rendering the grid, like normal grid like you might have in Maya, Blender of the engine, right? You want to render that every frame. So basically you give the data to the debug renderer, and the renderer renders that every frame. So resubmit the draw every frame, keeps track of it. But then the skeleton, I started to render in skeletons. You can see one in the previous video, and then I need to update the data every time. So I need to start to have bookkeeping. I need to start to be able to freeze stuff, update every frame, not update every frame. It was really complex. Instead, it was like, wait a second. Why don't I just submit that stuff every frame? Sure, I need to re-upload the data every frame, but this is debug. It is also a small amount of data, honestly. It's not going to be a big deal. And it's debug. I can simplify the heck out of it. And that's what I started doing. So if we go into the debug render, right? So there is a lot of stuff like, this is the old stuff that I'm progressively changing. But the way it works now is that you just have a slab allocator. Okay, so basically you have a GPU allocator, and you ask, okay, please give me X amount of memory, and then every frame that somebody has to render something, you just use this allocated memory, right? You can think of it as a stack. You keep filling it up. When it fills up, you ask another slab, another chunk of memory, and you start filling it up as well. At the end of the frame, you just say, okay, the memory is actually completely free. You can override it, right? So you're not allocating every frame. You're not freeing every frame. It's just a simple matter of zeroing out a counter. So that's how it works in the new way. So for example, if we go down to draw lines, here we go, you can see what happens. So here, basically I pad the color and the vertex. So I have vertex color, vertex color, vertex color to make it even simpler. In this way, I don't have to pass the color as a constant buffer. It's even simpler. Sure, it's a bit more data, but again, it's debug, it's not much data. But so, let's say here you have all your data. On the CPU, you go just to the slab allocator and say allocate. And it's going to basically copy that memory over on the GPU where it needs to go based where the allocator does. And that's it. Super simple, right? And then basically you just render everything. You render all these lines in one go. You can have mixed color lines in only one go in a single draw call, and so on. So that's how it works. Those are the old functions. You can see that they are not implemented. I just deleted them and left the stub. But they are mostly basically helper functions, basically function that builds more complex shape on top of lines. An example would be you want to draw bounding boxes. You just give me a series of bounding boxes, which is a minimum and maximum point. Inside here, I expand them to actually lines to draw a full box, and then I call draw lines. So basically just cascading messaging data. And for example here, it's not really pretty, but that's how I'm drawing the frustum, right? So I just say, okay, this is the camera, this is the color, do the computation to compute the frustum points, and then draw the lines, right? Not particularly pretty, it works. I don't want to spend too much time on it. So that's how it works now. So that's the first things I had to work to do, and I also had to write the allocator. So we can actually have a quick look at the allocator. And I started writing a Vulkan memory allocator, and I was like, okay, start working on it. Oops, this shouldn't be there anymore. And the more I worked on it, the more I realized this doesn't have to be a Vulkan specific. At the end of the day, how I handle the slab and the sub allocation is generic. As long as I have something that can allocate a chunk of memory for me, all those complex allocator can be built on top of that. And I actually realized, wait a second, I already have that. I already have buffer manager. So buffer manager is, we can see here, is a virtual, is an interface basically. And then I implement a Vulkan buffer manager and a DX12 buffer manager. So that's actually does the inner working on allocating memory on the GPU. Once I have that, everything I built on top doesn't have to be DX12 Vulkan specific. And this was the big realization, because this translates so much more. I don't need to have a DX12 mesh manager and a Vulkan mesh manager anymore, because with the modern API, a mesh is nothing more than a blob of data you load vertices to and indices. So once I have this, I can remove so many abstraction I had in my engine. I can push the level of abstraction down and not have to worry about that anymore. It's less code to maintain, less bugs to debug. So this was the big realization, because basically I started years ago making everything into a class. You know, like I would have done, I don't know, Vulkan texture, DX12 texture. Then I pushed it down one level, and it became managers. So you don't handle objects specifically, you just use a handle, which is an opaque handle, and you let the manager do stuff operation. So you just say, okay, bind this texture, update the values of this buffer, of this mesh, whatever, doesn't matter, right? But you let the manager do it. So the manager internally encapsulate if it's Vulkan, DX12, whatever it needs to do. But now with this, I can push the abstraction one level lower and just use the memory allocator, a GPU memory allocator. And once we have that, the mesh manager again doesn't need to be split anymore. And this was the big realization. That's basically what I'm working to, right? So the first things that I removed the abstraction was the debug manager, sorry, the debug renderer, because it was a DX12 and a Vulkan. I realized I don't need that. So that has been fixed, and I'm gonna apply that on so many other things on the engine. And that's what I had to fix. We want to have a quick look at the slab allocator, just to have a quick idea what's happening. When you ask an allocation, you basically just have a size in bytes, so how much do you want to allocate, and you have an initial data. So actually let me bigger. So that's the only thing you care. So first of all, we have some logic to figure out, okay, give me a slab. Again, here by a slab, I just mean a chunk of memory. And I think I'm using 4 megabyte or 60 megabyte slabs, which is pretty big, but it works fine. You can use a page allocator if you are more familiar with the term. But we have a slab index, so we're gonna ask, you're just gonna iterate the slab and say, can you allocate this much? If yes, I return you. If I don't find anything, I just allocate a new slab. Okay, and allocating a new slab is nothing more than going to the buffer manager and ask for an allocation. And that's it. And all the extra logic on top of that is using this slab. So basically, the slab returns me an index, so I know which slab to use. I access the array, I make the allocation, which returns me an handle, which you can use to update data or to free it later on. In this case, I'm not actually using the handle because I'm just freeing everything, but if you want to do different allocation strategies, you can. And then the only thing you care about is a range, which is an offset and a size. That's the only thing it is. So you know where in the slab you start and how big you are. That's it. So that's how it works. It's really simple, and then everything builds on top of that. The constant buffer manager it builds on top of the slab allocator as well now. So there was a lot of work done into that, and now it works quite well. There was all the work about the debug renderer and the camera. So those are the big technical thing, the back-end work has been done, and thanks to that the engine is becoming a lot cleaner. I like a lot more how it's structured and so on. So I'm gonna enjoy that until it lasts, because I'm sure that in a month or even less I'm gonna start to look at it again. It's like, I don't like it, it's too messy, and it will improve again. But so that's the current state. That was the big chunk of work that's been done on it. Next I'm gonna work on the culling, but I'm gonna make a separate video on the culling once it's working. So this is it. As usual, if you like this, subscribe, share it around. Any question, if you want to know more detail, let me know, and I'm more than happy to discuss any extra details you might want to know. See you in the next video.